Name is P. Ramadevi, lecturer in ECE. Today I am going to deal with the microwave communication and television subject. So today's topic is need of duplexer pulsar radar system. So in the previous session I have told about what is a radar, how it works, and what is the main principle of working, and what are the types of radars. So number of definitions which are involved in radar. When we are coming up with the radar systems, we have different types of definitions to be known, and we have done the derivation of radar range equation. Why? Because when we are having the radar range equation, we can determining the maximum range at which any target can be detected, and by using of that we can design a radar system, and we are having number of factors which are going to be affecting the radar performance also. So that is the main intention of the finding the radar range equation. So in the previous session I have told about the radar, what is a radar, what is the principles involved in that, and what is the working of a radar, simple block diagram of radar, okay, what are the definitions involved in our radar system, and what is a radar range equation. Okay, so in the previous session I have told this, and today we are going to be having a topics of need of duplexer, pulsar radar block diagram and its expression. So each block can be explained in this session, and what are the advantages and what are the disadvantages of pulsar radars. Okay, so when we are having this, first of all, in order to understand the pulsar radars, so first of all we have to know about the Doppler effect. Okay, so what is the Doppler effect means? Whenever we are having some source and destination, when we are having a source, that means whenever we are having a transmitter, it will transmitting some radio waves, and that waves are having a certain frequency of signals, and whenever we are going to be receiving some signals from the receiver, it is not having a same frequency of signals. So for that reasons, whenever we are using this, the difference between the two frequencies, that difference of frequency is going to be calling as Doppler frequency. Okay, so that is nothing but an which refers to an change in the wave frequency during the relative motion between a wave source and its observer. That means whenever the transmitter is transmitting some signals, the target is not in a stable position. It can be a moving position or it can be a stable position. Okay, so what are it? We can't predict that a target is nothing but a stable or a moving target. Okay, so whenever we are having some difference of frequencies from the transmitted signals and returning of the signals, that is echo signals, the difference frequency is going to be calling as Doppler effect, that is Doppler frequency. Okay, so that means we can have an example also. Why? Because whenever a sound is going to be appeared, whenever we stand on a platform in the railway station, the train is passing towards us is having a larger sound is going to be, that is increasing level of the sound. But whenever that train is passing away from us, it is having the sound is going to be very decreasing level. So that means the decreasing level of frequency and the increasing level of frequency, the difference between the two frequencies is going to be calling as Doppler frequency. Okay, so whenever the I have told about the Doppler effect by using a sound frequencies. Okay, like that whenever we are passing some signals also, it is also having a frequencies. Okay, the difference between the two frequencies is going to be calling as Doppler frequencies. Okay, so whenever the next topic is need of duplexer. So duplexer is nothing but a switch which is used to connect the transmitter and receiver to the same antenna. That means an antenna, to control that antenna as a transmitter and the receiver, we are having a control switch. That switch is going to be calling as duplexer. So duplexer is nothing but an which will acting as a switch which is used to connect the transmitter section or receiver section towards the antenna. Okay, just like a single pole double through. We have well known about the types of switches in our semiconductor devices. So in that, so in this we are well known about the single pole double through. That means this is the example, this is single pole and we are having double through. That means we can select this option, either that we can also select this option. That means a single switch can be operating as two. That's why it is going to be called as single pole double throw. That means a single ball hitting the two things. Okay, that means hitting is nothing but an, in our technical term, we are going to be connecting the two connections. Single pole double throw. We are having a single switch which is going to be used for connecting the two connections. Okay, like that it is nothing but an, a duplexer is nothing but an working as a single switch which is going to be used for connection of transmitter as well as receiver to the antenna. Okay, it just working as a single pole double throw switch. Okay, and it will permitting the same antenna to be used for both transmission and reception. So the main function of duplexer is nothing but an, it will isolates is nothing but an differentiates. Okay, so which will be used to differentiate the transmitter while receiving and isolating the receiver while transmitting, alternate vice versa. Okay, that means it will isolates the transmitter while receiving. That means whenever the receiver section is going to be on, the transmitting section should be off, and whenever the transmitting section is on, the receiver section should be off. So like that, which will be differentiating the operations by using the duplexer, and which will be protecting the receiver from high power transmitters. Why? Because if we are going to be using a same antenna for the transmitting and receiver section, it will be having a probability of getting the high power signals towards the receiver section also. If we are not going to use the duplexer, the high power signals which are going to be transmitted from the transmitter, that will be received by the receiver also. So in order to protect our receiver section also, we are having to use the duplexer. That is the main use of duplexer. Okay, and which will be help us a single transmitter or receiving antenna. That means instead of we are using the two antennas, only we are going to be using a single antenna for the operation of radar system. Okay, that is the main function of duplexer. So once again, the duplexer is nothing but a switch which is going to be used the transmitter or receiver to the antenna. Okay, and which will be acting as a single pole double throw switch. Okay, it will permits the antenna to be used for both the transmission at the same time reception. And the main function of duplexer is nothing but an which will isolates the transmitter section at the same time receiver section whenever it is going to be using one of the section, vice versa. If it will isolate the transmitter section while receiving the signals, and it will also isolates the receiver section while transmitting the signals. So like this it will isolates that signals. Okay, so that is the main function, and not only with that, which will protecting the receiver section from high power signals which are going to be transmitting from transmitter sections. The third one is, instead of using the two antennas, we are going to be using a single antenna for the both the transmitter and receiver. So we are having the cost is going to be less, the maintenance also is going to be less by using the single antenna. Clear? Yes. Okay. Next, here it is the diagram of pulsar radar block diagram. Okay, so instead of going for the pulsar radars, first of all we have to know about the types of radars. Okay, so whenever we are having the radars, which is going to be division into two parts, that is pulsar radars and continuous wave radars, that is CW radars. That means whenever we are transmitting some signals, whenever it is passing as a pulses, it is going to be calling as pulsar radars, and whenever it is using the continuous wave pulses, it is calling as continuous wave radars. Okay, it is differentiated based on the transmitting of pulses towards the target. Okay, so under the pulsar radars, it can be used for two parts, that is searching of radars can be done for the first time, and next one is the tracking radars. Tracking is nothing but an range, to find out the range or directions we are going to be using the tracking. Searching of radars means whenever it is a radar is going to be placed, another radar can be placed at a particular direction or particular location, and that is going to be sending some signals towards that particular location which is placed earlier. Okay, so by that we can search that particular radars. Okay, so like this we are having the pulsar radars is going to be basically based on our application. It is classified into two parts, that is searching radars and tracking radars. Okay, so the first radars are going to be basically division into two parts, that is pulsar radars and CW radars. Okay, whenever the transmitting the signals, based on that it is going to be division into two parts, and whenever the pulsar radars used in our application part, based on the application, it is classified into two parts, that is searching radars, tracking radars. And this is the general block diagram of pulsar radar system. Okay, so in the pulsar radar system, I have told that whenever we are using the duplexer, the single antenna can be used for both transmission and receiver section. Okay, and the antenna is going to be given for the connection of duplexer. The duplexer acting as a switch for both transmitter and receiver. That means it will just connect as an, if we are going to be using the transmitter section, it is connected to the transmitter, otherwise it is connected to the receiver. So vice versa, whenever it is going to be using either as a transmission section, it will off the receiver section, and whenever it is going to be using as a receiver section, the transmitter section should be off. So like this it can be used as vice versa. And you can see the block diagram, this is nothing but a transmitter section. This all block is going to be having as transmitter section, and the first one is pulse modulator. So it will be generating a train of pulses, and that train of pulses is going to be given for the transmitter. So the transmitter will transmit all of the signals towards the duplexer, and this duplexer is going to be having a switch, so it is going to be connected to transmitter and it will be off to the receiver section. And whenever we are having the duplexer is going to be given for the antenna connection. So this antenna is transmitting some signals towards the atmosphere. Okay, so which will transmit some signals, and this is the transmitter section. And whenever the target is going to be struck, that is coming into contact with our target, that signals, that echo signals can be received by the antenna. That echo signals are going to be received by the duplexer means, first of all I have said that it will be acting as a switch. How it will be acting as a switch? The frequency of signals which is transmitted, that frequency is not same with this duplexer. Why? Because it will note that it is not a transmitting section. Why? Because it is an echo signals which is having a difference of frequency. So that difference of frequency is going to be notified by the duplexer, and it will connect towards the receiver, not with the transmitter. And this is going to be given for the low noise RF amplifier. So any communication systems, whenever the antenna is going to be giving some signals, that signal should be, first of all, it should be amplified, and only the radio frequency ranges is going to be taken out by this antenna. Okay, so that low noise, why? Because whenever it is going to be striking towards the antenna, it is not only high power signals also, whenever it is having some low power signals also is going to be taken out with this antenna, and this is going to be amplified first, and that is going to be given for the mixture. And what is the use of local oscillator means, which will be generating a particular stable frequency is going to be generated, and whenever it is going to be using, first of all, in the receiver section, whenever we are going to be receiving some signals, that should be a high frequency of signals or low frequency of signals, it is to be processed. Why? Because for receiver or to monitor or to detect, to display, whatever it may be, for the output devices to be notified that, so for that the processing should be done. So whenever it should be processed, the RF frequencies directly is not processed. It is not easy to process the RF signals. So for that reasons, we are going to be converting into a intermediate frequency signals. So for this reasons, the local oscillator which will be generating a frequency which is in the range of intermediate frequency, and that frequency is going to be given for the mixture, and the RF frequencies or RF amplifier also giving some signals. So whenever it is going to be giving some signals, the mixture usage is nothing but an which will difference or which will sum. So the difference frequency should be in the ranges of intermediate frequency ranges. So that intermediate frequency of ranges are given for the IF amplifier, which will be amplifying the signal strength. That is going to be the signal strength is going to be increased in this session. So IF amplifier, which whatever it may be given, that is going to be given for the detector. So what is the use of detector means, which will be demodulate. That means the signals which are going to be amplified, that can be converted into a RF signals, which should be seen with our detector. Okay, so that signals will be detected, and that can be demodulated in this session, and that is going to be given for the video amplifier. Okay, so in the video amplifier, the name already suggests that which will be only amplifying the video signals. Okay, and that can be given for the display unit. So main intention of display unit is nothing but to display something, that is which is going to be used for displaying the information of the target. And it is not only the information, it can see with the range, at the same time height of the target. Okay, so that can be seen within this display unit. This is the basic block diagram of pulsar radar block diagram. Okay, so it is very easier to understand. Why? Because I have said simply, you can understand easily. Okay, so next is the what are the each block does, what it does. First of all, pulse modulator. So pulse modulator is nothing but which will be producing some pulse modulated signals, and that can be applied towards the transmitter. So what it does, what the transmitter does means, which will transmit the pulse modulated signals, which is nothing but a train of pulses, that can be transmitted to duplexer. So the duplexer is nothing but a microwave switch which connects the antenna to both transmitter section and receiver section alternately. So whenever it is transmitting some signals, the duplexer, what it does, only which will connect the transmitter section, not with the receiver section. So at that moment, the antenna transmit the pulse modulated signals through the antenna. Okay, so when the duplexer connects the antenna to the transmitter, similarly the signal which is received by the antenna will be given to the low noise RF amplifier. Okay, so that means whenever the duplexer connects towards the transmitter section will work. Whenever the signals are going to be received from the antenna, and it is going to be given for the duplexer, which will be acting as a receiver section only, not with transmitter section, that will be off. Okay, so that is the work of duplexer. I have already said in the previous slide, that is what is the need of duplexer and how it is, and what are the main functions of duplexer. Okay, and next one is the low noise RF amplifier. Low noise RF amplifier means which will amplifies the weak RF signals. and which is received by the antenna, and that output of the amplifier is going to be connected to the mixer. Okay, so whenever we are having connected to the mixer is going to be connected to a local oscillator. The local oscillator which will be producing a signal having a stable frequency. That means it just oscillates, or it just produces the signal, the certain frequency of signals only. Okay, and that frequency signals are going to be utilized for our processing of the signals. Okay, so the output of local oscillator is going to be connected to mixture, and the mixture, what it does means, which can produce the both sum and difference of the signals which are going to be applied. That means from the local oscillator is going to be giving some signals, at the same time the RF amplifier is going to be giving some signals, so which will be providing the both sum and difference of the signals, among which the difference of the signals will be of intermediate frequency type. Okay, that is nothing but I have told that from the mixer we are going to be getting the frequency range of IF frequency ranges, and that frequencies are going to be connected to IF amplifier. That IF amplifier which will be amplifying the intermediate frequency signals, and this IF amplifier only allows them intermediate frequency ranges of signals only, not with others. Okay, and it is mainly used to improve the signal to noise ratio at our output. I have already said that in the receiver section, most probably any communication devices, the input of the RF amplifier is going to be connected to the output of that particular next session, and the next session will be most probably IF amplifier only. Why? Because for processing of the signals, the RF amplifier directly it is not going to be processed. It can be processed only with intermediate frequencies. So for that we should be converted into IF amplifier stages only. IF stages only we have to convert. So for that reasons we are going to be using the IF amplifier at the receiver section, and the main intention of using the IF amplifier is nothing but to improve the signal to noise ratio at our output stage. Okay, and after the IF amplifier it is going to be given for detector. The detector is nothing but the name already indicates that detects the signals. What it detects, it will demodulate the signals which are coming from IF amplifier. That means the IF amplifier output is going to be detected, and it can be amplified the signals towards the original signals. And the next stage is video amplifier. As the name already suggests that it is a video amplifier which will be amplifies the video signals, and the output of the video amplifier is going to be given for display. So what it does means, in generally we have an idea about the displays. Why? Because almost all are having the idea about the monitors, computer systems, okay, TV, like that we are having number of sections to be there. Okay, so in this displays we are having the amplified video signals on CRT screen. Okay, we can see on the CRT screen. Not only with the CRT, we can also use our monitor systems, our TV monitors also. Like that we are having number of types of displays to display something about our target. That means to display our information of the target. What is the information means? It does only with the, what it does, the height of the signal, the height of the target, or the direction of the target. Okay, whether it is going to be moving or stable, like that it can be having some information of the target. Okay, this is the pulsar radar system block diagram explanation. Of each block I have explained in this session. And what are the main advantages of pulsar radar system means, it is very simple to understand, and it is very simple to design also, and it is very simple in operation also. Okay, and no need for accurate synchronization. There is no need of accurate synchronization. We don't use any synchronization circuits in our pulsar radar systems. And range can be increased by increasing the transmitting power. If we are having the range is going to be very higher at our target, we can increase the increasing of the transmitted signals. the power of the transmitted signal should be increased. Or if we having a range can be increased, means it can be increased by transmitted power, or it can be increasing of by increasing the diameter of the parabolic reflector of an antenna. Okay, we have well known about the antennas. We have having most of the having the ideas about the antenna. Why? Because antenna, in that antenna number of types of antennas are there. Under that we are having parabolic reflector antenna. Okay, so by increasing the diameter of the parabolic reflector, we can increase the range can be increased by increasing these two parameters. Okay, these are the advantages of pulsar radar systems. And next one is the disadvantages of pulsar radar systems. What are the drawbacks, advantages, disadvantages? Okay, so the first one is it cannot measure the velocity of moving target, but only can measure the range. It cannot measure the velocity of moving target. That is a main drawback under the pulsar radar system. And the next one is clutters can cause several problems. First of all, what is a clutter? Clutters are nothing but an which will term used for unwanted echoes in our system. Unwanted echoes means, for example, if we are having a fog in our atmospheric areas, or if any having some rainy areas, okay, if any having large trees, tall trees, if we are having some animals, insects, whatever it may be, it is having some difference in our atmosphere. Whenever we are using a radar, in that conditions, the echo signals which are returned from that from the ground or from the sea, from the rain, animals, insects, or any atmosphere effects, that will cause a serious performance in our issues with our radar systems. So that is going to be calling as clutter. Clutter is nothing but an, we have to if we are going to be remember of clutter means it is an unwanted echoes, unwanted signals. To be frank, it is nothing but an unwanted signals. So unwanted signals is nothing but an which are coming from our ground, sea, rain, animals, insects, atmosphere effects. So all of these are having number of conditions. We are going to be getting some echoes from other than radar. Okay, so that will be affecting of our performance of our radar system. So that is going to be calling as clutters. So like this clutters which will be causing a severe problems in our radar system. So in our pulsar radar also we are causing some problems in our radar system if we are going to be getting some clutters. That are the drawback of the pulsar radar system. And the third one is moving target cannot be detected. So that means the target should be in a stable condition. So in that conditions only the pulsar radar is going to be used. If the target is moving target, it cannot be used. It cannot be used, and if it is going to be used, it cannot be detected. First of all, okay. And in this we are going to be using parametric amplifier is high frequency low noise amplifier. Why? Because in our the receiver section, the first stage is low noise amplifier, low noise RF amplifier. So in that we are going to be using parametric amplifier, and whenever it is going to be used, it is having a high frequency low noise amplifier. So some drawback under the pulsar radars. Okay, first one is it cannot be measure the velocity of moving target, and whenever we are going to be getting clutters, it will be causing several problems in our radar system, and it cannot be detected the moving targets. Okay, and in this we are going to be using parametric amplifier. So these are drawback under the pulsar radar system. Okay, next. So for getting idea of the radar systems, I have done a quiz on this. So please note this question. That is, construction of pulsar radar is much simpler than the Doppler radar. Isn't it? Whenever we are having the idea of pulsar radars, I have told in this session. So whether it is much simpler than the Doppler radar, either true or false. So please note these questions. Why? Because It is very useful in our ESET examinations. So easily you can answer these questions whenever it is appearing into our examinations. Okay. Okay. So construction of pulsar radars, each is much simpler than a Doppler radar. Is it true or false? It is false. Why? Because this pulsar radar is the first type under the radar and the first introduced radar only. So it is very simpler to understand. It is very simpler in operation. So for these reasons, it is very simpler to use also. That's why it is a simpler than the Doppler radar. It is false. Next. So in our military applications, the radar cross sections of vehicles is minimized. Radar cross section of vehicles is minimized or not? Please note this question. Okay. So in our military applications, the radar cross section of vehicles is minimized or not? Whether it is true or false? Yes, it is true. Cross section of vehicles is going to be minimized in our military applications. And next. So a dash determines the target range by measuring the round trip time of a pulsed microwave signal. That means which is going to be used for determining of the target range by measuring the round trip time. That is, whenever you are going to be using a pulsar radars, if we are having some signals, the signals are going to be roundly, it is going to be rotating of the antennas. Antenna is going to be rotating, that is continuously, it is going to be rotating continuously, and that signals are going to be rotating in our atmosphere roundly. Okay, and by having this concept, we are going to be measuring or not. What type of radar is going to be used for determining the target in these situations? Okay, please note this question, please. Okay. A dash determines the target range by measuring the round trip type of a pulsed microwave signal, whether it is a pulsar radar, a Doppler radar, or cross section radar, none of the mentioned. So whether which type of is going to be radar is used. So in order to say this, first one is pulsar radar. Why? Because I have told about the pulsar radars. That means it is continuously passing some signals and it is determining the range, not with others. It is not going to be used for measuring the velocity. And we are not seen in this question that whether it is a moving target or stationary target. If it is having the moving target, it cannot be detected. Why? Because the pulsar radars cannot be used to detect a moving target. Okay, that is the answer about this quiz. Okay, next, radiometry is a technique or the principle on which radar works. Radiometry is a technique which is going to be using the radar system, whether it is true or false. Please note this question, please. Okay, that means whenever we are going to be radar is working, on which technique it is going to be uses. So radiometry is a technique which is used for having the processing of radio signals, radio waves, and that is a technique, and whether it is working on the radar system or not, whether it is true or false. It is false. It is not going to be using any radiometry. It just only works on the principle of sending some signals from the transmitter and receiving the signals from a distance of target, and that signals are going to be echo signals, and that signals are going to be received by the receiver. Simple technique. It is simple principle is going to be involved in our radar working. It is not going to be having any radiometry technique. Okay, so next question. The dash system obtains information about a target by transmitting a signal and receiving the echo from the target. So please note this question, please. So here it is saying that which system is going to be obtaining some information about a target and by transmitting a signal and receiving the echo signals from the target, whether it is a radar, whether it is the sonar, whether it is a radiometer, or none of the above mentioned. Okay, that means any system which is having some obtaining some information. Okay, in this session only I have said about the radar, and not only in this session, in the previous session also I have told the radar, that is nothing but an radio detection and ranging system. The name already indicates that which will be used for detecting the target, whether it is the type of the target or not, but the radar is going to be used for having some information about the target by transmitting a signal and receiving the echo signals from the target. Okay, the answer is radar. Okay, so radar is nothing but a radio detection and ranging system. Okay, by passing some radio signals from the transmitter and receiving some echo signals from the receiver from the target towards the receiver, and it is going to be processed, and it can be having some displays or any detectors, or it can be having some indicators to have a clear image of the target. Okay, like this it can be used. The next question is, the basic requirements of transmitting antennas are. Generally, when we are having some transmitting antennas, what should be there? What is the basic needs of the transmitting antennas? The first one is high frequency. The second one is low side lobes. If you are having some idea about the side lobes, means that is nothing but an whenever we are drawing the radiation patterns, the single direction radiation pattern is going to be calling as lobe. Okay, so it is having low side lobes or large signal to noise ratio, none of the mentioned. Okay, please note this question, please. And what are the basic requirements of the transmitting antenna is nothing but an whether it is having high efficiency, low side lobes, large signal to noise ratio, none of the mentioned. Okay, so what is the answer? Please note this question, then answer it. Okay, so what are the basic requirement of our transmitting antenna? Okay, high frequency, low side lobes, large signal to noise ratio, none of the mention. That is, high frequency is going to be the major requirement of the transmitting antenna. That means whenever we are going to be selecting the transmitting antenna for our radar system, first of all we should be choose the high efficiency of the transmitting antenna should be chosen. Okay, so that can be used for our radar system. Next, please note this question. Dash is a device that converts electrons to photons or vice versa. That is, it can be a device which will convert the electrons to photons or photons to electrons. Okay, so what is that device? Whether it is the antenna, electron gun, photon amplifier, microwave tube. What is the device used that is going to be used for converting the electrons to photons or photons to electrons, vice versa? So please note this question. Okay, the which device is converting the electrons to photons or photons to electrons? Okay, whether it is antenna or electron gun or photon amplifier or microwave tube. So what is the answer? Answer is A. The antenna is going to be a device which will be converts the electrons to photons or photons to electrons. Like this, it can be converting. It is having the capability to convert the electrons to photons or photons to electrons. So this is about the device. Okay, very much thank you about this. And in this session I have covered with the number of topics, that is what is the duplexer and what is the need of duplexer and what are the main functions of duplexer. Okay, so whenever we are using this pulsar radars, and what are the main block diagram of pulsar radars. Okay, so what are the main blocks which are going to be used in our pulsar radars, and what is the Doppler effect, and what are the main advantages and disadvantages of pulsar radars. And based on that we have done 3 or 4 questions. Based on that we are having some quiz on the pulsar radars, that is radar systems. Okay, so in this session we only concerned with the what is the use of duplexer, what is the need of duplexer, what is the duplexer, and pulsar radar block diagrams, and we have explained each block of the pulsar radar system. And not only with the each block, we are also concerned with our working of pulsar radar system. Easily I have told the what it does, and in this what are the advantages of pulsar radars, at the same time disadvantages of pulsar radars also. And whenever we are having the duplexer, not only with the need of duplexer, what it does, what are the main functions of the duplexer are also going to be seen in this session. Okay, so whenever we are having this session, if we understand this session only, we can understand the next type of radars. So it is the main topic to understand this session. Okay, so I am ending the session. Thank you so much.